Welcome to the 3D Altering 2D Pixel Art Workshop. This is Chapter 2 of our workshop series. In this chapter, we'll dive into a practical project focusing on the Blender software's Model Block Transform Voxelization feature. Within this feature, two parameters play a crucial role: octree depth and scale value. During this practice session, we'll explore the impact of these parameters on pixelating models, including first one, the influence of octree depth values on the transformation of models of different sizes. The second, common challenges and effects when using Blender's voxelization feature for complex model transformations. The third, the significance of scale value within Blender's voxelization feature. Let's get started and see how these parameters affect our pixel art transformations. What exactly is voxelization? Voxelization is a process that converts a 3D object into a block-like appearance, making it easy for coding and various applications. Next one is: what exactly is a 3D model octree? Well, think of it as a powerful spatial data structure used in the world of computer graphics and 3D modeling. Its primary purpose is to efficiently represent and manage complex 3D objects. How does it do this? By breaking down a 3D space that holds a 3D model into smaller, more manageable parts, often in the form of cubic regions or octants. To start, you have one large cube encompassing the entire model. Then, when needed, this big cube subdivides into 8 smaller cubes, and this process continues as necessary. The value of the octree in Blender tells us how many times we're going to divide the cube. In my exploration of voxelization and pixel art, I've divided my practice and experiments into two main sections. First, I've used straightforward mechanical models as my subjects for pixelation. These models provide a great starting point for understanding the voxelization process. The second section, however, delves into more intricate territory. Here, I've experimented with character models, which are notably more complex. These characters come with numerous curves and intricate details, presenting unique challenges and insights when it comes to voxelization. Now, let's begin by diving into the experiments with mechanical models. First test. We started with a cylindrical object featuring intricate triangular patterns on its surface. Setting the octree depth to 7 allowed us to capture fine details effectively. However, when we reduced it to 6, we noticed some loss of detail. Second test. Next, we moved on to a smaller component, initially assuming that an octree depth of 7 would work well for all object sizes. Surprisingly, for this particular component, an octree depth of 6 provided excellent detail representation. In fact, even when using an octree depth of 5, the smaller component still retained its fine details remarkably well. Third test. For our third experiment, we integrated the smaller component with the overall object, creating a large component with finer details. This time, using an octree depth of 5 severely distorted the appearance of the larger component, while going up to 7 restored its shape. However, this change led to a loss of detail in the smaller component. It was only when we tried an octree depth of 10 that the finer details of the smaller component were accurately represented. Outcome. These tests revealed a significant pattern. The effectiveness of octree depth in capturing object details depends on the overall size of the object silhouette and the size of its finer details. Larger objects with smaller details require a higher octree depth value to accurately depict the object's appearance. To optimize your modeling process, it's advisable to separate objects with intricate details from larger ones and assign them different appropriate octree depths. This will help achieve the best results in rendering your 3D models. The next section focuses on the application of insights gained from voxelizing the mechanical deconstruction model to character voxelization. The testing process has unveiled 4 key findings. Finding 1: voxelizing patterns featuring gaps can result in the loss of certain pattern elements. In character test 1, we can see 2 pattern examples with gaps, and some parts of these patterns are not adequately preserved during the voxelization process. Finding 2: thin and curved models, especially those like the character's hood and belt, are prone to developing holes during voxelization. Adjusting the scale value can impact the location of these holes, adding a weathered or worn appearance to the character. This is evident in character test 2. Finding 3: replicating the original facial model's appearance through block remesh can be quite challenging. However, it does offer the advantage of allowing the model to adopt various styles. In character test 3, we explore the presentation of the facial model at different octree depth values. Finding 4. When models of the same color overlap, they can become less distinct after block remesh. To create contrast and distinction, one can assign different colors to two overlapping parts, or apply significantly different octree depth values. Character Test 4 effectively demonstrates the impact of assigning vastly different octree depth values to two parts, emphasizing the contrast between them. Finally, let's discuss the scale value. Scale value, as mentioned in our previous tests, refers to the maximum value of 0.9 that can be selected within Blender's remesh block function. This parameter is crucial for controlling how blocks are arranged during voxelization. By adjusting the scale value, you have the ability to either emphasize or conceal specific visual details of the model while keeping the current octree depth setting. For instance, when dealing with mechanical block-type models, you can use the scale value to fine-tune how blocks are arranged, allowing you to highlight or hide particular model details. In the context of fabric structures or similar models, adjusting the scale value can also be helpful in concealing certain damages or worn-out areas, giving you more control over the voxelization process. In summary, the scale value is a valuable tool that enables artists and designers to precisely manipulate the voxelization process, making it possible to achieve their desired visual results, whether it's emphasizing specific details or concealing imperfections. And there you have it, our journey through the fascinating world of 3D voxelization in Blender. We've explored the impact of octree depth, the intricacies of scale value, and the various findings in voxelizing mechanical and character models. Remember, voxelization is not just a tool, it's an art in itself, allowing you to craft unique and visually stunning representations of 3D objects. So, whether you're a 3D artist, a game designer, or just someone with a passion for digital art, go ahead and experiment. Dive into the world of voxelization, explore the countless possibilities it offers, and let your creativity run wild. Thanks for joining us in this workshop, and we can't wait to see what incredible voxelized creations you come up with. Until next time, keep creating and keep innovating.